All right, let's go ahead and take a look at 9-4. So this one is one of the ones out of the textbook pages. So I am going to actually do practice and problem solving C. So if you see A, B, practice and problem solving C is the hardest of the pages. So I'm going to do that one totally. I'm going to do the entire thing. And then we'll talk about some of the other pages. But I think by doing this, it's going to demonstrate basically most of what we're going to need, what you guys are going to need to be able to do these problems. Okay, so algebraic representations of transformations, practice and problem solving C. So we're going to be writing an algebraic rule to describe each transformation of figure A to figure A prime. Okay, and then we're going to describe the transformation. So we've got our first triangle, which is A, which is this red triangle right here. Okay, and then after it gets moved, it turns into A prime, this green triangle right here. Okay, so essentially what's happening is in these problems, you're going to want to identify what type of transformation you're doing. And so remember, and I'm going to switch to the reteach page for just a second, just as a demonstration. Okay, remember that there are basically three types of transformation you're going to look at. Okay, you've got a translation where you're sliding the shape, you've got a reflection where you're flipping the shape, and finally a rotation where you are turning or spinning the shape. Okay, so when I go back and look at my problem here, this one doesn't really look like a flip, doesn't really look like a turn, right? It's just kind of A is just moving over and becoming A prime. A is just moving over and becoming A prime. And you can kind of see exactly what it's doing. Okay? So the trick is, though, is that it wants us to give this as an algebraic rule. And it wants us to describe it. So I bet you describing it for most of you guys is going to be easier. So I'm actually going to do that part first. Okay? So if we wanted to describe the transformation that's taking place from A to A prime, well, that looks pretty simple, right? It looks like it's a translation because it's just a sliding. So we're going to translate 2 units right. Okay? As in, I'm just going to slide it over 2 units. Okay? All right. Let's go ahead and now look at the algebraic rule here. And so the easiest way to do this is to actually look at these points and what changed. So I'm just going to look at these top 2 points. Okay, so we're going to call this one point A and this one A prime because that's going to be the, it's the name of the shape, but we could also make it the names of the points. Okay, so for point A, the coordinates of point A are going to be -1 and 4. Okay, whereas the coordinates of A prime, on the other hand, are going to be 1, 4. Okay, so you notice in that the only thing that changed here is my x-coordinate, which makes sense because if you move something to the right, the only thing that's going to change of those points is just the x-coordinate because you're still going to go up 4 units for the 4 and the y-coordinate. Okay, so the way we're going to start every algebraic rule is we're going to start it with x, comma y. So it's basically saying take the first point, which is going to be represented by x, comma y. We're going to draw an arrow, and then we're going to change these values by something, okay? So in this case, what happened to this -1, what happened to the -1 to turn it into a +1? Well, think about what would you add or what would you do to change -1 into +1? Well, the easiest way, and what we did in this case, is we added 2 to the x-coordinate. And then for the y-coordinate, well, we kept the y the same. So we're just going to write the variable y. Okay? So essentially what this is saying is take your x and y, take the x-coordinate and add 2 to it, take the y-coordinate and keep it the same. Okay? So as we go through these problems, we're going to be taking something that is in words, and we're going to be turning it into something that is algebraic. Okay? So let's go ahead and take a look at the next one. Okay? So again, the first thing we want to identify is what type of transformation are we looking at. Okay? And remember, again, our choices are, we can have a translation, which is a slide, a reflection, which is a flip, or a rotation, which is a turn? Well, this one's definitely not a translation. Okay, it doesn't look like we just slid A up into A prime. That wouldn't work, because that would be, we would end up with a rectangle that looks like A, that's kind of on its side like that, right? And we want a rectangle that's tilted, a rectangle that's up on its side. Okay, similarly, reflection probably isn't the greatest here either. Okay, because it doesn't really look like it's being flipped over any particular line, and it's definitely not being flipped over like the x-axis or the y-axis, which makes our life a lot easier if it's a reflection. Okay, so instead, this one is going to be a rotation. Okay, so we're going to rotate this one. Now, how do I make A into A prime? Well, you know, if you're on paper, this is pretty easy, but you're going to take your shape and you're going to rotate it up to A prime. Okay? So, sorry if you heard my dog there. Someone's at the door. Okay. So, how much am I rotating to get from A to A prime? Well, this looks to me like a 90-degree turn. Okay? It's moving from the fourth quadrant down here up into the first quadrant. So because it's only moving one quadrant over, that's going to be a rotation of 90 degrees. Okay? Now that rotation of 90 degrees, remember, because it's 90, we need to give a direction. Okay? So my arrows appear to be going counterclockwise. So please make sure, if you're going to do any sort of rotation where the direction matters, so for example, like a 90-degree rotation or a 270-degree rotation, be sure to tell us which direction you're rotating it, because that's going to matter, right? If you said 90 degrees clockwise, you're going to end up over here. Okay? We want to end up counterclockwise, so back that way. Okay? All right, so now, again, I'm going to pick out 2 points that correspond with each other, okay? So my easiest ones look like here. I'm going to use this point and this point, okay? And the reason why I'm picking those two is because that's where that point will end up after I do the rotation, okay? Because this one's the top right, and after I rotate it 90 degrees, it's going to end up here. Okay, so now let's look at the coordinates at this point. So for point A, this one is 4, -1. Okay, and this point is 1, 4. Okay, so this is something you want to be paying attention to. Notice that these numbers are very, very similar. Okay, I still have a 4 and a 1. Now, granted, the 1 has turned from a -1 in point A to a +1 in point 1. And we're going to talk about that one in just a second. Okay, but so let's just track this as we go. So, like I said before, every algebraic representation is going to start the same way, with x, comma, y. Because basically that's just saying take your first point and do something to it. Okay, so they're always going to start with x, comma, y. Okay, so now, what did we do with the x-coordinate? So before, the x-coordinate was 4, okay? Well, now, the x-coordinate is in the y spot. So that means, in my point, I'm going to end up with x in the y position. So notice how x has now moved to the back part of the point, because it is now representing the y-coordinate for my point. Okay? Similarly, the y-coordinate has also switched sides. So I know that I'm going to put a y in this first spot. Okay? But right now, I'm not done, because according to this transformation, the point 4, -1 would turn into -1, 4. And that's close, but remember, I want this to be a +1. Okay? So, how do I make a -1 into a +1? Well, that's pretty easy. All I have to do is make the y value its opposite. Make it negative. Okay? So if I take this -1 and I turn it into a positive, now I've got my transformation. So x, y rotates into negative y, x. Okay? And you'll notice, because those coordinates switched, that's what causes the rotation. Okay, so really what we're doing here is we're taking something visual and we're turning it into something that is algebraic. We're turning it into symbols. Okay, so every time you do one of these, I want you to start with the coordinates and work from there. Okay, so when you're trying to come up with the algebraic rules, look at the coordinates and compare them. What changed, what stayed the same, and then set up your rule accordingly. Okay, let's look at number 3 and number 4. So this one, they're giving me the rule. Okay, they're saying start with your point, x, y, make x stay the same. So my x coordinate is going to be consistent throughout this, but my y coordinate will switch to its opposite. Okay, so let's take a look at one of these coordinates and see what we have. So, for example, this point. Okay, so I'm going to label these with letters real quick just to make my life a little bit easier. So A, B, and C. So let's start with point B. Okay, point B has the coordinates 0, 2. Okay, so notice how if we follow this rule, my x coordinate will stay the same. So that means the 0, so when I do B prime, its coordinates, the x coordinate will be 0. Okay, and the y coordinate, on the other hand, we're going to take the y and we're going to make it its opposite. We're going to make it its negative. Okay, so the negative of positive 2 is negative 2. Okay, so now if I plot that point, I'm going to zoom in just a little bit to make this a little bit clearer. Okay, I'm going to plot the point 0, negative 2, and this is going to be point B. Okay, B prime, excuse me. Okay, so now we're going to repeat that process for the other points. So let's look at A prime. So the first thing we want to do before we can do A prime is we need to get the actual coordinates. So A is going to be negative 5, because I go left to 5 and down 3. So negative 5, negative 3. Okay, again, follow our rules. The x coordinate stays the same, and the y coordinate becomes its opposite. Well, what is the opposite of negative 3? What's the negative of negative 3? Well, if you remember, back to our integer work, a negative times a negative is a positive. Okay, so that means it's negative 5, comma, positive 3. So now let's plot that point. Negative 5, left to 5, and then up 1, 2, 3. I'm going to plot our point right here. And this one is A prime. Okay, so now if I start to connect, oops, excuse me, my Spotify's coming up. Okay, if we start to connect our points, we have one last one to do, but now you might be able to start seeing the pattern, right? Well, what happened to B and A? Well, it looks like they flipped over this middle line, which is the x-axis. Okay, so if we look at this, now if I wanted to, I could just do it the old-fashioned way. I could say that point C is the point 3, negative 3, and then go through and actually figure out what C prime is. Remember, the x would stay the same, and the y would be the opposite, so negative 3 would turn into positive 3. Go to plot my point, and I end up 1, 2, 3, somewhere up here. Okay, and now, if you didn't see it before, you will definitely see it now. I'm going to move this out of the way. Okay, my triangle has now flipped over the x-axis. Okay, and if you remember, what do we call a flip over the x-axis? That is a reflection. Okay, and remember, when you say reflection, you need to say over what line you're rotating, you're flipping it over, excuse me. So this is going to be reflection over the x-axis. Okay, we've got one more to do here on this section. So this one, again, is going to be very similar. So the first thing I'm going to do is we're just going to plot you can just figure out what these points are. So this is 3, negative 2, and this is negative 1, negative 2, and this is negative 1, 4, and finally 3, 4. Okay, so this one has us taking the points and just making them the opposite on both. Okay, so both the x-coordinate and the y-coordinate will turn into their opposites. Okay, so I'm going to do these one at a time. Okay, let's just take the first one. We're going to do 3, 4. Okay, so 3, 4, when I turn them into its opposites, is going to be -3, -4. Okay, and if I plot that point, -3, -4, that's going to put me somewhere down here. Okay, as I do these, I'm going to remove the work, or remove the previous point, just so I can kind of keep track of which ones I've already done, okay? Because one thing that can be a little bit tricky here is there's lots to do in these problems. It's not particularly difficult, but you want to make sure you're keeping track of everything you're covering. If you wanted to label your points, you could do that as well. This one's going to be a little too cluttered if I do that, but you can feel free to do that on your paper. Okay, so for the next one, 3, -2. Well, the opposite of 3 is -3, and the opposite of -2 is +2. So -3, +2 is going to put me somewhere about right here. Okay, our next point, -1, -2. Well, when both those negatives become their opposites, they're going to turn positive. So that's going to be +1, +2. I'm going to plot that point up here. Okay, and finally, +1, -4 is going to put me somewhere down here. Okay, so this problem, now what transformation we're doing here, we could actually probably answer this one in a few different ways, okay? And you might be wanting to say, this looks like a translation, Mr. Ferrari, because it looks like we're just sliding it 2 units down and 2 units left. And that is true. You could describe this transformation as a translation, as a slide, okay? But it turns out that actually what we've just done, okay, this thing that we've just done here is actually the transformation for a rotation. Okay, this is a rotation of 180 degrees. And if you notice, that's going to end up in the exact same spot, right? If you take that original printed rectangle and you turn your paper upside down, you will end up with the rectangle that I just graphed, the purple rectangle. Okay, so that is going to be a rotation of 180 degrees, okay? If this one had been a translation, instead I would have seen x comma y, and then it was left 2 and down 2. So it would have been x minus 2 and y minus 2, okay? But that's not what we saw. And so in that case, in this case, because of that, it would be equivalent, but it would not be the exact answer we're looking for on this problem, okay? Because this one should be a rotation. Okay, so we've got 2 left to do. These are number 5 and number 6. Okay, and then these ones are a little more, or at least for number 5, is a little more kind of open to us. Okay, so it says we have triangle ABC that has vertices at 2, -1, B at 0, 0, and C at -1, 4. And we want to state a rule for an algebraic transformation where vertex B will not be at the origin. Okay, so the best advice I can give you on a problem like this, if you ever see a problem that doesn't already have a graph, give it a graph. Okay, because it's going to be pretty hard for most people, don't want to say everybody, but for most people to be able to visualize this without actually graphing it. Okay, so if you don't have graph paper, that's okay. Just feel free to, if you sketch it, these numbers are pretty small. Just, keep your lines as straight as you can, and you probably can do it even if you don't have graph paper. Okay, but I went through, just for the sake of being able to describe this problem, I went through and I actually graphed this guy up here. Okay, so we are looking for a transformation that will make it so that this point, my computer is struggling a little bit this morning, that this point B is no longer at the origin. Okay, so, and if you remember back, we have 3 types of transformations for this section anyway. We have translations, we have rotations, and we have reflections. Okay, now if you remember, I'm going to do these kind of in reverse order. Okay, so reflections, those are a flip, and traditionally they are a flip over a line. Okay, and most of the time when we do reflections, we do them either over the y-axis or we do them over the x-axis. Okay, now take a look at point B, though, if you were going to reflect over either the x-axis or the y-axis. Well, remember that it's sitting right on both. It is on the x-axis and on the y-axis. Okay, and that means that if I were to do a reflection over that line, that point B wouldn't move. Point B would stay exactly where it is at the origin. Okay, and that is not what we want. So there are some reflections that exist that would make this one not be on the origin anymore. Okay, but for our purposes, a y-axis reflection or an x-axis reflection would not work for us. Okay, so I'm going to eliminate that one. Okay, now for rotations, similarly, now we had lots of different kinds of rotations. We had 90 degree, we had 180, we had 270. We could go clockwise, counterclockwise, right, with all of those. Okay, but we always did our rotations around the origin. Okay, or in other words, around exactly where point B is. Okay, so if the points are spinning around the origin, well, kind of similar to the reflection one. What's going to happen to point B if I rotate around the origin? Well, the short answer is it's not going to move as well, right? Because it's the point that everything else rotates around. So it stays in place. Okay, so that means that unless we were going to rotate around a different point, which is harder for us to do, okay, it's not normally something we deal with, okay, a rotation in this case, at least one around the origin, will not work in this case. Okay, so that leaves us with our last one. So obviously our answer has to be a translation, and honestly, translation kind of makes the most sense anyway, right? If my only goal is to move B somewhere else, well, what if I just translated it down, let's say 2 units? Okay, well, if I slid B down 2 units and made this B prime, well, now B is no longer at the origin. Okay, so any sort of translation will work for this one. So you could feel free to use mine, a translation of down 2. You could go down 3 and right 4. You could go up 10. You could do whatever you wanted as long as you do some sort of translation on this one. Okay, so I'm just going to put that in here, because it does want it, though, as an algebraic transformation. Okay, so think back to what we talked about before. We always, when we do an algebraic transformation, start with x comma y, because remember, that's the point we're starting with. Okay, and then I said for mine that I wanted to move it down 2. Okay, so if you remember, if I'm going down, the only coordinate that's going to change is my y coordinate. Okay, so I'm going to write in my x coordinate just as it is, and then I'm going to put y minus 2. Okay, and again, all that means, that minus 2 at the end just says, take my y coordinate and bring me down 2 units. Okay, so let's go ahead and take a look at our last problem, which is number 6. Okay, and again, just like before, I did graph this one, and I would recommend you guys do this as well. You can totally do this freehand. Okay, triangle LMN has L at 1, -1, M at 2, 3. Okay, and you notice it didn't give us the coordinates for N. Okay, that's going to be what we're looking for in this problem. Triangle L prime, M prime, and N prime has L prime at -1, -1, M at 3, -2, and N prime at -3, 0. And we want to find the coordinates of that missing point, of the original point N, and then we want to describe the transformation. Now, realistically, we're going to probably describe the transformation before we do the coordinates of the vertex. Because if we can't figure out what we're doing, it's going to be pretty hard to tell where N should be. Okay? So, again, this one is very hard to do if you aren't actually looking at the graph itself. So the first thing, again, I'd recommend is just graph it. Okay? And so I did that. Okay? So I plotted all the points. We have our N prime, L prime, and M prime triangle, making this really thin, obtuse triangle. Okay, and then we have in the kind of lighter purple the point L and point M. And again, our goal here is to find where this N prime point is going to move, where it moved from to give us back that N that we started with. Okay, and so again, one thing we want to keep in mind here is because these are the primes, because the dark purple ones are prime, those are our final transformation. So we essentially started with the light purple and are ending with the dark purple. Okay, so we want to keep that in mind when we describe our transformation. Okay, so let's look at each point individually. Okay, so for right now, I only want to look at my L's. Okay, and I'm going to look at the other ones in just a second, but I want to just use this to help me get started. Okay, so it turns out that L can be a little misleading if all I did was look at L, okay? Because there are lots of ways to do this, okay? So for example, I could move L to L prime as a translation. I could take L and I would move it 2 units to the left, and that would give me L prime. So that would be in a case of a translation, okay? I could also reflect it over the y-axis, okay? And that would cause L to flip. Oops, still in my highlighter, excuse me. That would cause L to flip and make L prime, okay? So I could do a reflection over the y-axis if all I was looking at is L, okay? I guess I should probably be writing these down. So we have a translation of 2 units left, potentially. We have a reflection over the y-axis. Okay, and then we can also do this as a rotation. Okay, if I take point L and I rotate it 90 degrees clockwise, okay, that will give me L prime. And if you don't believe me, take your paper and turn it 90 degrees clockwise, and you'll see exactly what I'm talking about. Okay, so this one could also be a rotation of 90 degrees clockwise. Okay, so we need to pick one of these 3 transformations, but only one of them can be the right answer. Okay, so let's go ahead and take a look at the other points now. Oops, as I'm erasing everything. Okay, let's look at the other points now and see if that will help. So now I am going to be looking at my other points. So I'm going to take a look at point M now. Okay, and so let's do the same transformations, because if it worked for L, it should work for M. It should be the same transformation for all of the points. Okay, so if I take point M, now I'm trying to move it to M prime. Okay, now if I go from point M and I translate 2 units to the left, okay, if I go 2 units left, that puts M prime over here. Okay, so obviously that is not where we want it to be. That is not down here with the M prime. So that means that number 1 cannot be the right answer. Okay, then that puts us to number 2, a reflection over the y-axis. Okay, well, if I'm reflecting over the y-axis, that would put M prime over here. Okay, and again, that is not where we want to be down in the 4th quadrant. Okay, so that means that one is out. Now, by process of elimination, we can probably maybe now just know that it's going to be a rotation 90 degrees clockwise, okay? But it's probably worth us looking at it, right? And again, take your paper, turn it 90 degrees clockwise, and you'll see that M rotates down and becomes M prime. Okay, so that means that we must have done a rotation of 90 degrees clockwise, okay? And again, clockwise because it's following kind of how the clock normally moves, okay? So, well, we've done half the problem now. We've described the transformation. It's a 90-degree clockwise rotation. Now it's just a matter of figuring out where N was, okay? And so again, if we look at these, now I'm kind of working backwards. I'm going from the prime back to the original. Okay, so essentially I'm reversing that rotation of 90 degrees clockwise by making a 90-degree counterclockwise turn. Okay, so that would mean that N prime, take your paper, rotate it 90 degrees counterclockwise now, and you'll see that it will rotate to 0, -3. Okay, so that means that that must have been my N. And again, if I connect these, it might be a little bit easier to see. Okay, how those 2 shapes kind of turn into each other. Okay, the purple shape, if you turn it 90 degrees counterclockwise, right, against what the original transformation would have been, you'll get back to what you started with in L, M, and N. Okay, so let's look at the coordinates now. Again, this is going to be an x coordinate of 0 and a y coordinate of -3. So that puts us, N is 0, -3. Okay, so that will do it for the C page. Now, this is the hardest of all the pages, as I said at the start of the video. Okay, so when you go back and do A and B, this one should be a little more straightforward now. Use this as your model. And again, I want to point out, I know I looked at it earlier. Okay, so first of all, this reteach page is going to be your best friend. It has all the definitions you need. As far as what a translation is, what a reflection is, what a rotation is. But also I want to point out to you guys, this table is going to be really valuable, okay? Because if you're looking at an algebraic rule and it gives it to you in one of these forms, okay, you can kind of, based on the look, tell which one it's going to be, okay? So look at this table, because this is going to this reteach page is going to represent a pretty good page of notes for you guys to kind of work from, in addition to the stuff that I've already helped you with. Okay? That's going to do it for this video. Thanks for watching. I'll go ahead. I'm going to be posting the rest of this section throughout the day today, so please feel free to check back. And like I said, I'm going to keep these going with every video. And also Miss Gorilla is going to be helping me kind of keep up on this, because the next few sections have a few extras. It's going to be pretty tough for me to do them by myself. So again, thanks for